Hi guys, it's Daniel here, and today as a last minute AIME 2 prep, I'm going to try to solve, or not solve, I'm just going to try to explain as many AIME 1 problems as I can in 20 minutes. Alright, so without further ado, let us begin. Timer start. Okay, so we have 15 distinct points on a triangle ABC. So let's draw ABC. So we have ABC with 3 points on AB. 1, 2, 3, 4 points on BC, and 5 points on AC. And then we want to find the number of triangles with positive area whose vertices are among these 15 points. Alright, we want a triangle, so that means we need 3 vertices. So out of these 15 points, we want to choose 3 of them to serve as our vertices. However, this triangle has to have positive area, which means that we cannot have a triangle with all 3 vertices on one side. In particular, we have to subtract the number of triangles, triangles with air quotes, that have all 3 vertices on side AB, which is, there's 5 points in side AB, and we choose 3 of them. And then same thing, we also need to get rid of all the triangles with all 3 vertices on BC, which has 6 points. So 6, choose 3. And then finally, same thing with AC, which has 7 points on it. So our final total is 15, choose 3, minus 5, choose 3, minus 6, choose 3, minus 7, choose 3, which is, if you evaluate it, equals 390. So that is our first answer. Alright, next problem. Okay, problem number 2. Alright, so if we have each of these numbers divided by m, then we get a remainder r. And for each of these numbers, if we divide it by the number n, then we get another remainder s. Then we want to find m plus r plus s. Okay, so if we divide each of these numbers and get a positive integer, or divide it by positive integer m and get a remainder r, if we divide the difference between two of them by the positive integer m, we should get a remainder of 0 since the remainders cancel out. In that case, if we take the difference of 787 and 702, and this equals 85, then 85 is 0 remainder when you divide it by m, so that means m divides 85. Similarly, 855 minus 787, which is equal to 68, should also be a multiple of m. So that means m must be the greatest common factor of 85 and 68, which means m is 17. Now we know that m is 17, we can find the remainder r. And we can just choose any number and mod it by 17. And in this case, the remainder is 5. Alright, so now we do the exact same thing on the other side. So 722 minus 412 should be a multiple of n. And in this case, this is equal to 310. We also have that 815 minus 722 is equal to, let's see, what is it equal to? 93. And this is also a multiple of n, so that means by taking the greatest common factor, n is equal to 31. And we can find the remainder by taking any of the numbers mod 31 to get 9. So our final answer is 17 plus 31 plus 5 plus 9, which is equal to 62. And that is our answer. Alright, next problem. So, we have a positive integer n. Dn is the units digit of this expression. And we want to find the remainder when we sum this and then when we divide it by 1,000. So we have to be careful here because this is the units digit of this number, alright? So that means we can't just sum this number. We can't just plug this number in here and then take mod 10 and then mod 100. That doesn't really make much sense. We actually have to first take this mod 10 and then put it in the summation and then divide it by 1,000. So how do we find this mod 10? Well, there really isn't any easy way to find it at the first glance. So what we basically do is we make a list of what dn mod 10 is. So starting from when n equals 1, the mods are 1, and then we add 2 to get 3, add 3 to get 6, add 4 to get 0, since we're working mod 10. Now we add 5, add 6, add 7, add 8, add 9, add 10, add 11, add 12, add 13, add 14, add 15, add 16, add 17, add 18, add 19, add 20, and then add 21, and then it cycles. So we have that dn mod 10 cycles every 20. And then in particular, that means each of these blocks appears 100 times in this summation, because 2017 divided by 20, well, that's 100 plus a little bit left. So we have each of these blocks being happening 100 times, and since the sum of all the numbers in one of these blocks is simply equal to 70, then the sum of them in 100 blocks is 70 times 100. And finally, we have out of the 100 blocks, we've taken 2,000 of this elements in the summation, so we still have the final 17 left, which are just going to be the first 17 here, which in fact is just equal to 70 minus 1, which is 69. 69. And then, well, what's this equal? This is 7,000 plus 69. Well, when we divide by 100, then this just all cancels out. So our final remainder when we divide by 1,000 is 069. And that is the answer. Haha, the answer is 069. We get it. Let's move on now. Problem number 4. Alright, a pyramid has a triangular base with sides 20, 20, and 24. Alright, so let's draw that really quick. Okay, that was a really bad base. Okay, so this is the base of the triangular pyramid, and I will draw another one that will represent the actual pyramid. Okay, and I don't know where the final vertex is, so I won't draw that for now. So we have that the three edges of the pyramid are, let's see, so the edges from the fourth vertex to all three vertices is 25. So, and we want to find the volume of the pyramid. Okay, so where exactly is this fourth vertex? Well, we do know that the fourth vertex has this same distance from all the vertices of this triangle. And in the plane, well, what is the locus of all points that have the same distance from all 3 points? Well, in order to answer this question, we should first answer the question, what is the locus of all points that are equidistant from 2 points in the space? So if we choose these 2 points, we see that the locus is simply the plane that bisects this segment right here. So it should be this plane, and this also extends down here and to infinity in all directions. But in particular, this plane contains the perpendicular bisector of this segment. And then this is true for all 3 planes as well, all 3 segments as well. The locus is, again, the plane that is perpendicular to that segment and the plane perpendicular to this final segment. And the locus of all points that are equidistant from all 3 points is just going to be the intersection of these 3 planes, which is in particular just going to be a single line that passes through some point here. And what is this point here? Well, it's simply the circumcenter, because the circumcenter is equidistant from all 3 points of this triangle. So now we know that locus of all points that are equidistant from 3 vertices of the triangle is simply the line perpendicular to the plane that the triangle resides in that passes through the circumcenter. Okay, so now let's let this 4th point be here, and then let's let the distance from this 4th point to the triangle be h, because in order to find the volume, we have to find h. Okay, so first step, how do we find h? Well, if we draw a right triangle here, then this height is h. We know that this hypotenuse is 25, and then we finally know that this leg right here is r, where r is the radius of this 20, 20, 24 triangle. So we have that h squared plus r squared is equal to 25 squared. Okay, but we have 2 variables here and only 1 equation. How do we solve this? Well, we do know that this triangle is a 20, 20, 24 triangle, so we can actually find the circumradius. There are multiple ways to do this, except for, I think the easiest way is to use the formula that the area, k, of this triangle is equal to a times b times c, the product of the sides divided by 4r, where r is the circumradius. So in other words, we have that r is equal to abc over 4k. Thankfully, k is very easy to find in this because this is an isosceles triangle, so once we draw the height from the vertex, this turns into 12, 12. Oh look, we have a 12, 16, 20 triangle, which means that the area k is just going to be 12 times 16. So this is going to be 20 times 20 times 24 over 4 times 12 times 16. Okay, yeah, this stuff all cancels out, and it turns out that this stuff is going to end up 25 over 2. Okay, So now we know that r is 25 over 2, so we have that h squared is equal to 25 squared minus 25 over 2 squared. So we can first factor out a 25 squared from here to get 25 squared times 1 minus 1 half squared, which is 1/4, which is just 25 squared times 3/4. So that means h is equal to 25 root 3 over 2. Okay, so finally we're almost done here. In order to find the volume of the pyramid, we need to know that the volume of the pyramid is 1/3 times the area of the base, which is just k, times the height, h, which is 1/3 times, let's see, the area is going to be ABC over 4r. Well, okay, the area is 12 times 16, right? So this is, k is 12 times 16, h is 25 root 3 over 2, and then this turns out to be 800 root 3, which means that our final answer format is m root n, and we want to find m plus n, so our final answer is going to be 803, and we are done. Okay, next problem. We have a rational number in base 8 is ab cd, and then same number in base 12 is bb.ba, and we want to find abc. So in case you're not familiar with base numbers that have decimals, this is just equal to 8a plus b plus c over 8 plus d over 64. So this kind of makes sense, right? Because in decimals, we have that the first digit after the decimal place is c over 10, and then the second one is c over 100, and so on and so forth. So it's the same analogy right here. So we have that this thing is equal to 12b plus b over 12 plus a over 144. Okay, so we have this equation. But in fact, we know more than this, because this part is an integer, and this part is a decimal that's between 0 and 1. And this is an integer, and this is a decimal between 0 and 1. So in fact, we have that this part is equal to this part, and we also have that this part is equal to this part. So in fact, we have two equations to work with here. In the first equation, we have 8a plus b equals 12b plus b, implies that 2a equals 3b, simple enough. So now we have the next equation. So we have that c over 8 plus d over 64 is equal to b over 12 plus a over 144. So first off, let's try to clear denominators here and multiply both sides by 144. This gives that, let's see, what does c equal? 18c plus 9/4 d is equal to 12b plus a, and we already know that 12b is equal to 8a, so this is equal to 8a plus a, which is equal to 9a. So now we can divide both sides by 9 to get 2c plus d over 4 is equal to a. So now we know that c and a are both integers. In fact, they're integers between 0 and 9. So that means d over 4 must also be an integer. And we know that d appears in the base 8 number, so d is in fact strictly between 0 and 8. The only way for d over 4 to be an integer, satisfying that restriction, is d equals 4. So now we have that 2c plus 1 is equal to a. So now from back here, we know that a is a multiple of 3, and from here we know that a is odd. So a is an odd multiple of 3. And again, we see that a appears in the base 8 number, so that means a is strictly between 0 and 8. The only odd multiple of 3 between 0 and 8 is going to be 3, so a equals 3. Which means that c equals 1. And then looking right here, b equals 2. So that means a, b, c is going to be 3, 2, 1. We're done. Okay, next problem. Problem number 6. Okay, so a circle is circumscribed around an isosceles triangle. So we have a circle here, sorry, bad circle, and we have an isosceles triangle with angle x, x, and 180 minus 2x. Okay, 2 points are chosen uniformly at random, and a chord is drawn between them, and we want to find the probability. Well, we know that the probability that they intersect this triangle is 14 over 25, and we want to find the difference between the largest and smallest values of x. Okay, so let's think about how to do this here. Well, instead of counting the probability that the chord intersects the triangle, let's try to find the probability the chord doesn't intersect the triangle, because that seems a little bit easier. In order for the chord to not intersect the triangle, both points have to lie strictly within a single arc of this triangle, right? So since the points are uniformly chosen in these arcs, well, the probability that the point is chosen in this arc is just going to be x over 180, right? Because, well, this arc has length 2x and the entire circle has length 360, so the probability is going to be x over 180. And the same thing for this one. It's also going to be x over 180. And for this one, the probability is going to be 180 minus 2x over 180. Okay, so now we have that x over 180 is the probability that we choose this arc right here for the first point, and then we have to multiply by x over 180 again for the probability that the second point appears there. And then this is the exact same thing for this arc right here, so that means we multiply this by 2 to account for both of them. And finally, we have the probability that both points lie on this arc, which is just 180 minus 2x over 180 squared. And this is going to be 14 over 25. So right now we have some really, really big numbers here. We definitely do not want to square 180. So instead, let's do the substitution at y equals x over 180. And then that gives 2y squared plus, well, 180 minus 2x over 180 is just 1 minus 2x over 180. So this is 1 minus 2y squared equals 14 over 20. Oh, made a mistake here. This, in fact, is not 14 over 25. The probability the chord intersects the triangle is 14 over 25. So the probability that the chord does not intersect the triangle is 1 minus that, which is 11 over 25. Don't make this mistake on the AIME 2, alright? Don't be like me doing this video. Alright, anyways. This is 11 over 25, so that means if we keep on going, 2y squared expand. Yes, yes, yes. Calculation. We get it. Equals 11 over 25. And then we get the 6y squared minus 4y plus 14 over 25 is equal to 0. Okay, so now let's suppose we want to find the difference between the largest and smallest values of x. So that means, well, if we just find the difference between the largest and smallest values of y, then that means we can just multiply by 180 because of this equation to get our answer. So let's let y1 and y2 be our roots, and we want to find y1 minus y2. Well, we do know that y1 plus y2 is equal to 2/3 by Vietas, and y1 times y2 is equal to 14 over 25 divided by 6, which is equal to 7 over 75, again by Vietas. So y1 minus y2 is equal to the square root of y1 plus y2 squared, because this turns into y1 squared plus 2y1 y2 plus y2 squared, and then we have to subtract 4 y1 y2. Alright, if this doesn't make sense, square both sides and then expand everything, and you'll see that this is true. So we plug this in 2/3, and then we plug this in 7 over 75. Okay, everything so good so far. And then finally we get that if we do all the calculations, I will omit them for now, that this is going to be 4 over 15. Okay, so now we know that y1 minus y2 is 4 over 15, but we want to find x1 minus x2. In other words, since x equals 180y, we have to find 180 times this value. So 4 over 15 times 180, and this is just equal to 48. So 48048 is our answer, and we are done. And we have 1 minute left, so I don't think I will be able to finish 7, but I will try it to get as far as possible. So we have a plus b is less than or equal to 6, and tab is equal to 6 choose a, 6 choose b, 6 choose a plus b, and we want to find the sum of all tab where they satisfy this. So we want to satisfy the sum less than or equal to 6 of tab, where tab is going to be equal to that. Well, this is just equal to the sum from I equals 0 to 6 of the sum of t let's see, a plus b equals I of TAB, right? So what is the sum of, what is this thing? Well, actually, we should first probably sub in T. Okay, so 5 seconds left, and since this is a video and not the actual AIME, I'm going to be nice and finish this up. Alright, okay, maybe you heard the timer just go off, but yeah, well, I already started, so let's just finish this up. So, this is 6 choose A times 6 choose B times 6 choose A plus B. Oh, look, we have A plus B equals I here, and then this is 6 choose A plus B, so we can just actually substitute I in for this. I equals 0, 6 of this thing. Well, 6 choose I, well, I is independent of A plus B, so we can bring it on the outside of this summation, multiplied by sum from A plus B equals I of 6 choose A times 6 choose B. Alright, so now how do we evaluate this? Well, there's an identity called Vandermonde's identity. I think I talked about it in a previous video. So if I did, I'll put a link right here. But in any case, it turns out that using that identity, this is just simply going to be 12 choose A plus B, which is just going to be I. Alright, so we have that this is the summation from I equals 0 of 6 choose I times 12 choose I. Or we can write it in this form, because we want to use Vandermonde's identity again. 6 choose I, well, actually let's do 6 choose 6 minus I times 12 choose I. Okay, so now this we can use Vandermonde's identity again, even though I does not range from 0 through 12. When I is greater than 6, then this thing just turns into 0, so we can essentially ignore all the other terms and just use Vandermonde's identity from I equals 0 through 6. It's the same thing, but this just equals, let's see, it should equal 18 choose 6. Okay, so now we have 18 choose 6. We can just take a mod 10 after finding the remainder, and let's see. If you bash it out and find the remainder when you divide by 1,000, this should be congruent to 564 mod 100. So 564 is the answer, and we are done. So 7 problems in slightly over 20 minutes. I think that's not such a bad turn up here. So thanks for watching, and good luck on the AIME 2.
Hey guys, I'm here back with another math video. Today we're going to be doing AIME 2017 problem number 8.